reason that you need to know is that if we have a tangent drawn to a circle, okay, remember a tangent does what?
Just touches
Just touches the circumference. Yeah. Lovely. So if we have a tangent drawn, and if we can see that a radius is drawn, so if a line is drawn from the centre to that tangent, it means that this angle here is going to be 90 degrees. Okay? So a tangent meets the radius at 90 degrees.
Was the other one 90 degrees too?
Yes. Yes.
They're both 180.
Why does the statement sound so professional? Like, it's
The tangent to a circle is perpendicular to the radius at the point of contact.
like that's so many more words than what
It's just like the line.
Okay, so maybe you want to write the words I just said. The tangent meets the radius at 90 degrees. Okay? Remember, these are your notes. So and I admitted I snipped it from a book. So I thought it was the easiest way around it. So you didn't have to draw lots of diagrams. So the tangent meets the radius at 90 degrees. Now, just be careful because sometimes they'll have a diagram, they'll have a tangent, and they'll have a chord. Okay? So the chord doesn't meet it at 90 degrees. It must be the radius. Okay? You clear on that?
It must be the radius?
It must be the radius.
Okay, not just like a chord.
Is that, you have more of that.
The radius so it has to be perpendicular.
No, if the radius touches the tangent, it will be perpendicular always. Okay?
Could it be the diameter as well?
Yes.
Yeah,
Does that mean if we are drawing a line from
You wouldn't normally. Alright, okay. Now, tangents from an external point are always equal in length. So, if I trace this random point P, you can see P is outside of the circle. If I were to draw two tangents, so PA is a tangent and PB is also a tangent, okay? So these two lengths here, where it touches the circle edge, these lengths would be equal. Okay? So I've chosen a random point P, I've drawn tangents to the circle.
You can lock it.
Alright, so these two lines here are equal. Okay? Now, connecting to that, this one up above, if I were to draw lines here and lines here, these are both radii, yes? Which means that these angles here must be 90 degrees. Okay? So we can work with this to actually get more and more information.
Wait, what angles would be those two? The A and B?
These would be 90 degrees if you had added in the two radii.
Because
Because the radius meets the tangent at 90 degrees.
what's the tangent?
This line PA is a tangent.
Oh, okay.
Okay? You're clear on that? Lovely jubbly. Also within this, so that's if you had drawn that, but knowing that they are two equal in length means that this would be an isosceles triangle, yes? So had you seen a chord drawn here, joining up A and B, then this would be an isosceles triangle. So there's lots of different ways that they can use these angle regions. And there's lots of different diagrams that you can have. There's no way that I'm ever going to be able to teach you every single kind of question that you could get, but you just need to pick out the correct angle reason from it. And in a similar way to the other questions that we had before, I said that you may all have different answers. You may all have different answers and different ways of doing these kinds of things. Some may be quicker than others. one is not right, the other is not wrong. Okay, they could both be correct. You just got a different route.
What does it mean tangent to an external point? It means on the outside.
So P is an external point, it's not within the circle.
So are not tangents not just in the circle?
What they mean is that they both start at the same point. So if I had a circle here and I had that tangent and that tangent, that I'm not saying anything is the same length here. It's only when they meet at a point P. Yeah? And what's the little information I've given you? If a circle, if a circle can be drawn through 4 points, we say the points are concyclic. Okay? So these points here would be called concyclic because they've drawn we've been able to draw a circle. And this shape here is called a cyclic quadrilateral. Okay? It's a quadrilateral within a circle. It's a cyclic quadrilateral.
Could that also make a bow tie?
You could make bow ties from it, yes, but this terminology I'm getting you to look for here is just that if a quadrilateral is completely inside a circle, when I say completely inside, I mean that the 4 vertices meet the circle edge. So not this. Oh, that's a triangle. Not this. Okay, that's not a cyclic quadrilateral. This one would be.
What
Yes?
is that?
Which is a shape.
Okay, so that's
Okay, so that's not a cyclic quadrilateral because the vertices don't touch the circle. It's not the same. Alright, now here's information about cyclic quadrilaterals. The opposite angles of a cyclic quadrilateral add to 180. So if you do have a 4-sided shape drawn within a circle, this angle here plus this angle here would make 180. Okay, so those opposite angles in a cyclic quadrilateral would add up to be 180. And obviously the other two would add to be 180 as
Wait.
well.
Oh, okay.
No,
No, yeah.
they've just chosen to label them with Greek letters. Do not question labeling. Alright, now the exterior angle of a cyclic quadrilateral is equal to the opposite interior. What did we talk? We had a reason similar to this before, remember? What was that? With the triangle. Do you remember what that one was?
It was like, the 2 over here are equal to the 1 that's over here.
Yes, so the exterior angle of the triangle was equal to the sum of the 2 interior opposite ones. Yes, remember that? So this is kind of similar, but this exterior one is just equal to the interior opposite one. But the reason behind it is connected to this one here. Okay, because we know that this one plus this one is 180, and we know that this plus this is 180, which means that those two have to be equal to each other.
Wait, why does it say O1 equals O2? Shouldn't it just O equals O?
Well, sure, they've missed the 1 and the 2 there.
So O
You
equals
can
O.
see, sure. They just need these equal to each other. Add 1 and 2 if you wish. One of, it doesn't matter which one. Yeah, we all good? Okay, alternate segment theorem. Again, I don't know if I'm just a bit special, but I always think of wind surface when I see this one. So here's my board and here's my sail. I don't know.
But the sun
I don't know how it's special. You can think of it however you wish. Well, some people say this is the sun. But this is my, anyway, here's the tangent. Okay, so we've got a tangent touching a circle edge. Note, this one doesn't have to go through the centre. Okay, so it could, but it doesn't have to. If this did go through the centre, we would know that this total angle here would be 90. Alright, but it doesn't. This one doesn't. We have a centre on here. The alternate segment theorem states that this outside angle here is equal to the inside opposite. Okay, so this is my outside angle. It's equal to this inside opposite. Now, obviously, I've got two different outside and insides, so that's why we've got the different colours. So this one here is also equal to this one here. Now, those bits of information can often help, but you are often also needing to include other reasons. We also know that this total angle, the green angle, would be what? 180. So you can work out these two bits, and then you can know that this one takes it up to 180. As I said, it's really, really difficult for us to be able to cover every single type of question that you might get. You just need to have enough practice of them, recognising all of these different reasons and applying them to different situations.
You're trying to add this on.
No, because this whole one is equal to this. It's not just up to the circle. Oh wait, it might still that. So this whole angle there is my diagram not good enough? Okay, so that's the whole thing there. Alright? Chord bisector. Okay, bisecting something means, we talked about it a minute ago? Cutting it into two equal parts. So if I had a chord here, and I were to cut it in half, and a chord here and cut it in half, okay, if I was to do perpendicular bisectors, it means that they would meet in the centre of a circle. How interesting is that? This is probably the least needed information. Okay, so I'm going to put a brush around that one. It's not as important. These last two are creeping their way in to a few more questions. So, you do need to make sure you've learned these. I can never remember which order it goes in. So here we go. We've got two chords. Yes, you happy with that? A, B is a chord, and C, D is a chord. Now those two chords happen to meet at point P. Alright? If I were to multiply AP, which is this bit, by this measurement here, BP, it would give me the same answer as if I multiplied this by this. Okay? So the situation you might have is that they've perhaps given you three of those numbers and asked you to find the fourth. Okay, so the two blue ones multiplied together would equal the two red ones multiplied together. Okay, so that's if two chords meet, so the chords equal each other. Not necessarily, no. This measurement multiplied by this one would equal this one multiplied by
Oh
this.
yeah. Oh yeah.
Okay?
Wait,
It's not adding. It's not, you're not adding them.
does DP equal what? This DP,
DP and PD are the same.
yeah, but does DP multiplied by AP equal the same thing?
No. So it has to be on the same chord.
Okay.
Yeah, so you've got to make sure you've got those letters in the same order. The correct order, yeah. Intersecting chords outside the circle.
Oh yeah.
Alright, so this bad boy's got, here's our chord CD, and we've extended it out to P. And this one's AB, and we've extended it out to P. AP, so this long chord here, multiplied by PB, so just this bit, is equal to this bad boy. Oh, shush now. Multiplied by this bit. Okay, so the long multiplied by the bit outside is equal to the long multiplied by the bit outside. Alright, so as I said, these last two are creeping in more and more into the exam. You may not get them at all, but just make sure that you are aware of them. So as I said, this sheet here, the summary sheet, has all of those angle meters on there. Okay, so it's just really going to be a case of you practicing enough questions to be able to apply these rules to anything. Okay, we've got 5 minutes.